This is AQA A-Level Maths, Paper 3, 2023. So this paper is the pure and statistics paper. So the first question is on absolute values. And, first of all, we're going to have to look at how the graph is being transformed. If we just imagine we had y equals the absolute value of x, it would look something like this. Okay, but this is actually being shifted some amount to the right and then some amount down. Okay, apparently those numbers are 2 and 3, or -2 and -3, we don't know which one. But if it's being shifted 2 to the right, that means the x becomes an x minus 2. If you just remember your transformations from GCSEs, it becomes f of x minus 2 inside of the brackets. And then outside of the brackets, because we're shifting down, we'd subtract 3. So this would be the answer. Trapezium rule, which one is an overestimate? Well, we can just draw this in and see which one gives us an overestimate. So if you just draw in a trapezium there, that looks perfect, it's flush. It doesn't look like an over or underestimate. This one here does look like an overestimate because the area of the trapezium is greater than the area of the curve. This one here, this one looks almost flush, but because there's that curve to it, this will actually be a bit of an underestimate. And then this one here is a bit of a weird one, but if you just draw in a couple of trapeziums, you'll notice that this is also flush. This is more of a Tamura style question. So we've got a curve, y equals f(x) passes through this, and the gradient at 3 is 0 apparently, and we need the normal. So if the curve just looks something like this, and we've got this point here 3, 7, and the gradient is horizontal, so 0, then the gradient of the normal would just be straight up like this, right? So that means it's just going to be the equation x equals 3. Okay, because it's this line here, and that's the line x equals 3, so that's the answer. We're just splitting this up, so this is 5 over x squared minus the cube root of x over x squared. This is just x to the power of a third. Okay, and then this here is 5x to the minus 2, and then here we're just subtracting the powers. A third minus 2 is just minus 5/3, and that's your answer. We've got this equation, and we need to find the gradient of the curve at the point where y equals 10. So let's first of all just differentiate. When we differentiate an exponential like this, we differentiate the power, we bring it down, and then we multiply it by that same exponential unchanged. Okay, so this becomes 3 lots of e to the 2x multiplied by the differential of 2x, which is 2, and you bring that down here. So it is 2 times by 3e to the 2x. Okay, that gets us 6e to the 2x. We don't know what x equals, and that's what we need. Alright, so we'll just plug y equals 10 into this, because if we've got a y value, we can get an x value and vice versa. So we've got 10 equals 3e to the 2x. Divide by 3 on both sides, l on both sides, and then a half both sides to get that for x. So just plug that in. You'll get this. The 2 and the half cancel, so you just get ln of 10 over 3. E and ln are inverse functions, so if you raise them to the power of if you raise e to the power of ln, they just cancel, so this just becomes 6 times by 10 over 3, which is just 20. Now there's a shortcut to this question, which is how I think they intended you to do it, but if you differentiate it, you'll get 6e to the 2x, as we already know. But if we rewrite this as 2 lots of 3e to the 2x, 3e to the 2x is just y, right? So we can just replace this with y. Okay, and we know that y equals 10 at this point here, so we plug in 10 there and get 20. Also is our answer. We're sketching this curve. Okay, so we've got roots at x equals 0. This one here must be repeated. Okay, and then we've also got another root at x equals minus a over 2. Okay, if we just set that equal to 0, it's the line y equals 0 here. Okay, so we need to touch this point here once, so we need to touch this point here twice. Okay, and it's a positive cubic, so it's going to go from here up there. So we need to go up here, touch this once, like that, touch this twice, so here and then like that, and it should look something like this. We've got polynomial p of x, and we're told that x plus 3 is a factor. By the factor theorem, that implies that x equals minus 3 is a solution. So if you plug in minus 3, this all becomes 0. I've just realised here I put f of minus 3 when I meant to put p of minus 3. I misread that, but that's fine. So if we plug in minus 3 here, we get minus 3 squared, so that's 9. This is 2 lots of minus 3 plus a, and then plus 36. This is 9 times by minus 6 plus a, so minus 54 plus 9a plus 36 becomes 9a equals 18, so a equals 2. State the transformation which maps the curve with this equation here onto this. If you look at the x's are all the same. The only thing that's happened is we've added 36 to the end. So if you imagine this, if this is y equals f of x, this is y equals f of x plus 36. Okay, with the plus 36 being outside the bracket. So all we've done is translated it up by 36. So it's a translation by 0, 36. We've got this polynomial here, as we already saw earlier, and apparently it can be written in this form. This tells us that -3 is a solution, so it has at least one solution. Okay, and we need to show that somehow b squared is less than 8c using part A and part Bii. This is part A, and this is part Bii. So part Bii was just showing that it was a translation, and part A was just sketching the original curve. Now, if you look at this, so how do we get from this to this? Apparently we've translated it by moving it up by 36. Okay, so we've gone from having two distinct solutions to only one distinct solution. Okay, so if this new curve, right, is this here, okay, and it has only one distinct solution, that solution just must be this one here, x equals -3. Okay, so if this is the only solution, if x equals -3 is the only solution of this curve here, which is this, and that must mean that this here, this quadratic, must have no solutions, which means that this discriminant must be less than 0. Okay, so b squared subcheck 4 times by 2 times by c is less than 0, and that gets us b squared minus 8ac is less than 0, which is b squared is less than 8c, which is what we wanted. We're finding the area of this shape here and showing that it equals that. If this full thing here is 5 across, this must be 2.5 and this must be 2.5. It's the same circle, and all we've done is taken two sectors of it, and if O is the center of the circle, then PO is the same distance as OQ, so both 2.5. This here, OS and OR are radii of the circle, so they're also 2.5. Okay, I'll just start by finding the area of this sector. Now the area of a sector in radians is given by half r squared theta. R is 5/2, and theta, well, let's just have a look at what theta could be. It's not this theta here. If this full angle here is pi, okay, then if we remove this angle, it becomes pi minus theta. Pi minus theta must equal this angle here plus this angle here. Okay, but because these are congruent sectors, that must mean if we half the angle, so pi minus theta over 2, that gets us the angle of one of the sectors. So this here is pi minus theta over 2. Okay, so the area of this sector is half r squared pi minus theta over 2. And we need to times it by 2 because we've got two sectors. So if we do that, we'll get just whatever. You'll get 25/4 times by this. Okay, and that's the area of both the sectors combined. Okay, now we need the area of this shape here. The easiest way to do this is just to draw a line from R to S. There is a few different ways to do this. You can even use the cross product if you do further maths. But half AB sine C is probably the best way to go. If you look at the answer that they want us to give, it has sine theta in it. So that's a very big clue that we need to use sine something. So half AB sine C is the only one that we know to do with area. Okay, so half AB sine C is just going to be half 2.5 times 2.5 times sine theta. Okay, and then we also need to times it by 2 because we've got this triangle here and this triangle here, which are both congruent, and that gets us 25/4 sine theta. And so the area of this full shape is just this plus this. So these two plus these two. If you just go ahead and factor out 25/4, we'll get this angle here plus this one here. You can multiply back out to check that is actually the same thing. Times sine theta by 2/2, and then we can just join it with this here to get that, and then factor out the half from this, so this becomes 25/8 times by pi minus theta plus 2 sine theta, which is what we wanted to show. So we want to either maximize or minimize A. There's a big clue that we are going to be maximizing it. So A is this, okay, and it's either maximized or minimized when the differential is equal to 0, because then we'll have a stationary point where the graph is a maximum. So if we just differentiate this, you can just do it like this because this is a constant term, so you don't have to worry about any product rule. But I'm just going to head and distribute the 25 over 8 just because, so it's a bit easier didactically. This here is a constant, so that's just nothing. We're differentiating with respect to theta, so this becomes minus 25 over 8. And this just becomes 25 over 4. Sine theta differentiates to cosine theta. This must equal 0, as we already know. Just rearrange, divide by 25 on both sides, times by 8 on both sides, and then divide by 2 on both sides to get cosine theta equals a half. Cosine theta equals a half implies that theta equals pi over 3, which is indeed our answer. And we need to show that it's a maximum because it says fully justify your answer. So we need the second differential. If we differentiate this again, this becomes a minus 25 over 4 sine theta. Cosine theta differentiates to minus sine theta, so this becomes minus. So we'll get this. Okay, and if you plug in pi over 3, this is just obviously going to be negative, therefore it is maximized. Find the exact maximum value of it. Well, it's maximized when theta equals pi over 3, so if we just plug in pi over 3 and just collect, we'll get this as our answer. Without further calculation, state how your answers to part BI and BII would change if PQ were increased to 10 meters. So this PQ here was originally 5 meters, but it's increased to 10 meters. Okay, so this here was 2.5, which means it must have increased to 5. Okay, so what we've essentially done is we've doubled the radius. Now, we know that the area is originally maximized when theta equals pi over 3, that's part BI, and then BII said that the max area is this. Now, I'm not going to do, maybe this is kind of cheating by doing further calculations, but I'm only doing this to show you why the answer is the answer. You could just do this intuitively though without having to do the calculation, but I'm just showing you just so it's a bit easier to understand it. But if we've doubled the radius, okay, then r squared must have increased by a factor of 4, right? Because if we double r, then r squared would be times by 4, because 2 squared is 4. So if we're multiplying the area of the sectors by 4, that means the area of the full shape is going to multiply by 4 as well, because we used it for this triangle here as well as for the sectors. Okay, so the total area would increase by a factor of 4, but this angle here, pi over 3, would stay the same, right? Because if we increase the length, say if we had like this length and we increased it like this, okay, well that's not going to change what this angle here is, even if we increase this length, right, which this one would increase because it's the radii of the circle. If we say just drag it along, it's not going to change this angle, so the angle is going to remain the same, but the area would increase by a factor of 4. Use the substitution u equals x to the 5 plus 2 to show that this equals that. Let's first of all just change the limit. So when x equals 1, okay, we'll plug in 1 into this, you'll get u equals 1 plus 2, so u equals 3. When x equals 0, u must equal 2, because 0 to the 5 is 0 plus 2 is 2. And then if we differentiate this, we'll get du by dx equals 5x to the 4, and then the plus 2 just goes away. So if we rearrange for dx, just multiply it on both sides, then divide by 5x to the 4 on both sides to get this. Okay, and now we can start changing stuff around. X to the 5 plus 2 is obviously just going to be u, because that's our substitution. So this bottom part becomes u cubed, and then this top part we'll just leave it for now. And we also need to remember to change the limits. The dx changes to a du over 5x to the 4, because that's what we got here. The x to the 9 cancels with the x to the 4 a bit to get x to the 5 on top. Okay, and x to the 5 is a bit easier to manage, because if you look back at the substitution that we have, first of all I just took out the 5th, but it doesn't matter whether you do that or not. But if you look at the substitution here, if we subtract 2 from both sides, we get u minus 2 equals x to the power of 5. So x to the power of 5 here just equals u minus 2. And then now we can just split this up like a very simple integral. So this becomes u over u cubed minus 2 over u cubed. U over u cubed is just 1 over u squared, which is u to the power of minus 2. And then this is just minus 2u to the minus 3. Okay, and now we can just start integrating normally. So increase the power by 1, divide by the new power to get this, and then just plug in 3, and then plug in 2 afterwards and subtract them. Okay, the 5th remains on the outside. Just simplify it slowly. It's a show that question, so you do want to show every single step. You'll get down to this. Eventually this becomes 1 over 36. So a 5th times by 1 over 36 is 1 over 180, which is what we wanted to show. So we've got parametric equations here. Most of this is actually waffle. We don't really need to read all of this just yet. But we just want to show that the height between P and Q is less than 7 meters. Okay, now P is just when T equals 0.2 and Q is when T equals 3. So if we plug in T equals 0.2, we can get what the X equation equals. But you can see here that because it's at the origin, we know that it's going to be 0. You can just plug it in if you want. You will get X equals 0, but it's just a bit quicker if you can see that it's just definitely going to be 0. Now plugging in T equals 0.2 into the Y equation, we'll just get 10.2. Just use a calculator if you prefer. But as a shortcut, 2 over 0.2, what you're doing is 2 divided by 1 over 5. But dividing by 1 over 5 is the same as timesing by 5. So here we've got 2 times by 5, which is 10, plus 0.2 is 10.2. We didn't actually need to work out the X values because we're only looking for the change in the Y values. But I'm still going to work out the X coordinates because that might be useful for later on in the question. Now at T equals 3, let's look at point Q. If you just plug T equals 3 into the X equation here, we'll get X equals 112 over 15. And then if we plug T equals 3 into the Y equation, we'll get 11 over 3. So this is 112 over 15 and then 11 over 3. Now the distance, the vertical distance, must be 10.2 take away 11 over 3. And if you do that, you'll get 6.53 recurring, which is less than 7, so that is fine. Find an expression for dy by dx in terms of t. If x equals this and y equals this, so we can just differentiate dx with x with respect to t and y with respect to t, and then form an equation which is dy by dx. 1 over t is just t to the power of minus 1. This differentiates with respect to t as 1 minus minus 1 t to the power of minus 2, and then the plus 4.8 just goes away because it's a constant. Now with this one here, this one's a bit more simple. It's 1 minus 2t to the minus 2. Okay, now we're looking for dy by dx, not dx by dt and dy by dt. But dy by dx can be written as dy by dt times by dt over dx, because then these dt's cancel and we get dy by dx. We've got dy by dt, so that's just that, that's fine. And then dt over dx is just this, flipped over. So we've got 1 over this entire thing here. Okay, and then just collect them together. This times by 1 is just itself. And that's our answer. Find the length rs. Okay, rs is apparently the lowest point, so we've already differentiated. Okay, and the lowest point here, you can see it's stationary. Okay, and if it's stationary, that means at that point the derivative must equal 0, because the gradient when x equals whatever the x value of this is must be 0. Okay, so this equals 0 times by 1 plus t to the power of minus 2 to get this. Bring this to the other side, and you get t squared equals 2, which implies that t equals plus or minus root 2. However, the question says that t is between 0.2 and 3 inclusive, so it can't be negative, so therefore t must just be t equals root 2. And then we actually need to find the length rs. Now, let's just look at the point. I don't know which one I did first. It's just the height. Okay, so we know that s is just going to be from 0, so we're just looking for the y coordinate of r. Now the y coordinate is given by this, so if we just plug in root 2, we get root 2 plus 2 over root 2, which is approximately 2.83 meters. And so 2.83 take away 0 is just 2.83, so that is the answer. I don't know why that's there. I forgot to animate that apparently. We're looking at the angle that the slide makes with the horizontal at Q. So if you just imagine you draw a line in here and then we draw a triangle, so this triangle here. Okay, hopefully you can see that, but I've just redrawn that triangle here, and we're looking for this angle here because that's the angle that we make with the horizontal. Okay, so if that's the case, okay, let's just look at the first differential. We just need to find it's what is it? It's when t equals 3 here, because q is when t equals 3, as it says down here. So if we plug in t equals 3, we can get what the gradient is here. Okay, and that becomes 7 over 10. So it's not actually perfectly flat. It's 7 over 10. But the gradient, if you think about what it actually is, it's the change in y over the change in x, the difference in y over the difference in x. Which means that for every 7 that we go up, we go 10 across, right? So this gradient here must actually, it would probably be better. It would actually be this triangle here, sorry, not the other one. Okay, so it's this triangle here. Okay, so this must go 10 across and then 7 up, and so the angle must be this one here. If you just imagine you drew one in there, okay, and that's the angle theta. And so theta is just given by, well, the opposite over adjacent, and then we do the inverse. That's that. So tan theta equals 7 over 10, and theta must equal 35 degrees if you just use inverse tan on both sides. Now, an interesting thing that comes off this is whenever you work out a gradient, that gradient just equals tan. I'm assuming the angle is actually in the right place, so maybe just check that the angle is in the right place, and it's just tan of that angle, because if you think about what tan is, it's opposite over adjacent, i.e. change in y over change in x. So tan of theta is just actually the gradient, which is quite a useful trick to know. We're on to the stat section now. So the product moment correlation coefficient is a value which is between -1 and 1. So if it's either perfectly negative or perfectly positively correlated. So this here is the only one which is outside that range. It's -1.2, so this must be incorrect. If you have events that are mutually exclusive, then that must mean they can't happen at the same time. So for example, if I flip a coin, I can't get a heads and tails at the same time, so the probability of heads and a tails on the same throw is impossible. It's 0, assuming you can't land, you know, halfway between the two. So this is the only correct one. We've got a driving test here, and I think this is a binomial distribution. Yeah, I think, does it say? Yeah, it is, because it's binomial B here. Okay, you kind of just have to remember the assumptions that you need for the binomial distribution. There are a few, but just put down any one that you know. It's the probability of passing the test remains constant. It says in this context, so you do actually need to use the context, otherwise you won't use the mark. Otherwise you won't get the mark. You could also say that there's a fixed number of trials. You could say the event of passing the test is independent of not passing the test. A bunch of different things. Part B here, find the probability that exactly 7 of the drivers pass. Well, if it's distributed by this, just put this into your calculator, probability x equals 7. Your calculator does this all for you, you get 0.0157. At most 16, so that means x needs to be less than or equal to 16. That equals 0.908. And then find the probability that more than 12 pass. Okay, well that's the probability that x is greater than or equal to 13, which is 1 minus the probability that x is less than or equal to 12. If x is going to be greater than or equal to 13, okay, the reason why it's equal to this is because we want 13, 14, 15, 16, all the way up to 32. But instead, let's look for 0, 1, 2, 3, all the way up to 12. And because that's the region that we're not looking for, we'll do 1 minus that to just get the region between 13 and 32 inclusive. Okay, put that into your calculator, you'll get this, which is 0.538. Find the mean number of drivers. Well, the mean of a binomial distribution is given by NP. This is in the formula booklet. So that's going to be 32 times 0.4, which is 12.8. And the standard deviation is it's going to be the square root of NP 1 minus P. The variance actually is NP 1 minus P. And because variance is just standard deviation squared, and variance is 7.68, the standard deviation must just be 2.77. Okay, so you square root variance to get standard deviation. I've used S here instead of sigma because I've assumed that this is actually just a sample instead of a population. There were deduct 2 marks for it at regular level maths, but you should keep it in mind if you do further maths. So we've got 2 types of coin in a box, and we want to find the probability that they're both of the same type. So you could either get 2 bronzes or 2 silvers. So a half times a half, or a quarter, sorry, an eighth times an eighth. And we're adding them together because we're getting this or this. Okay, that's just simple GCSE maths. Find the probability that both the coins are bronze, given that at least one of the coins is bronze. This one's a bit more tricky, but being at least one bronze is, first of all, either we can get having at least one be bronze is having them both be silver, except it's not that. Okay, so it's 1 minus the probability of both of them being silver. So either you could get a bronze and a silver, you could get a silver and a bronze, you could get a bronze and a bronze. Okay, so you could calculate those three probabilities instead of doing this. This is just a bit quicker, it's up to you. That comes out at 63 over 64. Now, the probability of both of them being bronze is just going to be a half times a half, so a quarter. Now, given that at least one of the coins is bronze, so it's this given this. Okay, if it's this given this, it's the probability of this happening given that this has already happened. So it's out of this. Okay, so it's this out of this. In other words, it's this out of this written like that. Okay, so it would be a quarter divided by 63 over 64. Hopefully that makes sense. This is more of like an intuition. Like this question mostly assesses intuition, I think. This is called conditional probability. You can have a look at this thing called Bayes' theorem, which goes into quite a few questions like this. You might find it interesting, but this would be a quarter over 63 over 64, which comes out as a ninth. Here we've got the normal distribution question. So say the probability of the mass of the aluminium cans recycled on any given day is not equal to 24,500. Because the normal distribution is a continuous distribution, the probability of equaling an exact number is infinitesimally small, and so you would just call it 0%. It's not actually 0%, but it's so small that we just consider it to be 0%. Okay, which means that the probability of not having that must just be 100%. It's 1 minus 0, so 1. Okay, so having exactly 24,500, 0.000, exactly that is infinitely small, so the probability of not having that must be 100%. Here we're doing a hypothesis test. Okay, we've got this many kilograms of aluminium over a 24-day period, but our we're doing it on a daily basis, so we're looking at like the daily change. Okay, so if we say X bar is the mean mass of recycled cans, okay, and we've got a null hypothesis of 24,500. Where is that? Yeah, up here. Okay, because that's just a base claim. Okay, it's sticking true to what we already believe, and then the alternative hypothesis is the suggested change, so that it's changed. So it's not increased nor decreased necessarily. We don't know which one. It's just that it's changed. This implies it's a two-tailed test. If this is over a 24-day period, if we divide by 24, we'll get 26,730 per day. Now, the way that you do a hypothesis test is that you assume the null hypothesis to be true, okay, and then you examine what happens under the null hypothesis. And if the null hypothesis is giving you results that seems too extreme, or keyword significant, then we can reject it if that seems too unbelievable, shall we say. So X bar is distributed normally with a mean of 24,500 and then a standard deviation of 5,200 over root 24, or sigma squared of 5,200 squared over 24. Okay, the reason why it's over 24 is because it's just the reason why it's over 24 actually, why it's sigma squared over n, comes from further maths. There is like a proof there for it. It's not really A-level territory, but I might do a video on normal distribution explaining stuff like this. But I'm sure you'll know this result anyways because you'll have practiced it tons of times. Now, the standard deviation here, as I said earlier, is 5,200 over root 24. So that's the value you want to be putting in your calculator. Okay, now what do we need to check? We need to try and check whether it's greater than this or less than this, okay? Whether X bar is greater or less than that. Now, the way that we know which one to check is, well, we compare it to our mean. Okay, we're expecting 24,500, okay, but the suggested mean is 26,730. So they're actually suggesting it's more than that. If they're suggesting it's more than that, then we need to be looking at the upper tail. Okay, so we're looking for the probability that X bar being greater than 26,730 is an anomaly. Okay, this is 1 minus the probability of x, that should say x bar, sorry, being less than 26,730. We don't need to change this at all because it's a continuous distribution, so it doesn't affect it, because the probability of one of them would just be 0, so it doesn't matter whether we increase or decrease it. You just put this into your calculator, you get 0.018. Now just be careful about the significance level, because it's a two-tailed test. We're going to have a significance of 2.5% in each tail, so alpha actually equals 0.025. Now 0.025 is actually greater than 0.08, so we actually reject h0, because the probability of this occurring is so small that it causes us to doubt how believable the h0 is, because if under h0 we're seeing a result that extreme, even less so than the level of significance, then we can assume it's not true. Okay, so therefore we reject h0. There is sufficient evidence to suggest the mean mass of recycled aluminium cans has changed. A member of the council claims that a different sample of 24, it's basically saying if you took a different sample, the results would be the same. It's not necessarily true though, because the sample mean could change. It would likely be different, so the result of the test could be different, so the claim could be wrong. Careful, it's not will be wrong. It could actually be the same for very specific samples. It's not necessarily incorrect, but he could be wrong. Okay. This is the large dataset question, so this is just a waste of time. So the interquartile range is the upper quartile subtract the lower quartile. If you did foundation maths, then you should be able to do this. The median is given to you, and everything else is given to you. So you just plug in the values. 1.5 times by 403 is less than the median plus 1.5 times by 403. You simplify to get that. That means the mass is only going to be between these two, okay, as per the rule. So anything outside of this range must be removed, so that would be 2040. The statistical name for the mass that should be removed, it's an outlier. Okay, you could say anomaly too, but I don't think that's in the mark scheme, so just stick with outlier. The probability that n is between 1 and 5, exclusive with 5 but inclusive with 1, so between 1 and 4 inclusive. First of all, we need what k equals. If we have a set number of outcomes, okay, then that must mean the sum of the probabilities of each outcome must equal 1. Okay, because say if I flip a heads, either I get a heads or a tails. Okay, a heads or a tails will always have a probability of 1. If I roll a die, getting a 1 or a 2 or a 3 or a 4 or a 5 or a 6, assuming it's between 1 and 6, is going to be 1. Okay, because I will definitely get one of those. So the probability of getting at least one of any of these would just be 100% if we do that once. Okay, so if we add all the probabilities up, we get 1. That gets you this, so k equals 0.08. And then we just sum up the ones between 1 and 5, so 0.37 plus 0.9k plus 0.25 plus 0.4k, where k is 0.08. That gets you 0.724. Now the large data set, so we want to take a quota sample of 200 cars. Well, in the large data set, there's 5 makes of cars, okay, across the 2 years that the large data set is over. So if we just pick 20 cars of each make from each year, so that means in 1 year we'll have 20 times by 5 cars, so that's 100, and then the other year we'll also have another 100, so that makes up the 200 that we need. Describe one disadvantage of quota sampling. It could produce a biased sample. With this, you kind of just have to know your sampling methods. To be honest, I think it's kind of a waste of a question to ask. But it's just something you have to know. This is just the type of thing that you watch a quick video on 5 minutes before your test. You could kind of just think about it and give yourself an example of where you would use a quota sample, and then just make up disadvantages which seem reasonable. Anyways, the probability that d is less than 5.2, this is normal distribution. If x is distributed normally with a mean of 6.5 and a variance of 0.73 squared, then the probability that d is less than 5.2 is going to be this, if you just put it into your calculator. D is greater than 7, That's 1 minus the probability that d is less than 7. Okay, we don't need to change this number here because it's normal, and the value is d is a continuous random variable. So just put that into your calculator, you'll get that. Find the proportion of apples that the supermarket accepts if it's between 5 and 8. So we want d to be between these two. So we want d to be less than 8, and we need to subtract the probability that d is less than 5. Okay, that gets us between 8 and 5 if you just draw a normal distribution curve, the bell curve. Again, just put it into your calculator, you'll get this. I can't really offer much guidance with these questions because they're all just calculator. They're just testing whether you can use a calculator, which you should know how to do. But yeah. Here, so this question is on the standard normal distribution. Okay, so we've got a distribution with a mean of 0 and then a standard deviation of 1 and a variance of 1. Okay, and now the z value, so along the x-axis, each x value is just the z value, is what we call it. And this comes from, first of all, we take our observed value, so in this case, for the first one, it would be 5.9, and we shift it by the mean, okay, and then we scale it by the standard deviation. Okay, if you imagine it's like a transformation, if we're subtracting mu, we're moving it to the right by whatever the mean is, and then if we're dividing by the standard deviation, we're effectively timesing all of the x-coordinates by sigma. Okay, now the probability that z is less than that specific z value corresponding to the standard normal distribution curve, that's apparently 0.6. Okay, and the probability that z is greater than this one here, this observed piece, this observed event, is 0.2. Okay, the normal distribution, the standard normal is that if you just draw the curve, it looks like that. I'll just quickly go ahead and explain, but if this is z for the first one, okay, then that means the area to the left of it is 0.6, and say if this is, I thought I was going to do the other one first. The other one, the z here, and then 0.2 here. Okay, so this 0.6 would be this full area there, and then the 0.2 would be this full area there. Okay, and we're just looking for what values of z actually give us an area of 0.6, and the value of z which gives us an area of 0.2. Now to do this, you just do the inverse normal on your calculator. It's just plugging the numbers into your calculator. I mean, mu equals 0, sigma squared equals 1, and yeah, just inverse normal it. Just put the area 0.6 and 0.2. Sorry about that. Somebody came in, so I kind of lost my thought process. But okay, so if you just do inverse normal on your calculator with an area of 0.2 and 0.6 respectively, and then mu is 0, and then sigma as 1, you'll get 0.2533 for this z value, and then for this z value you'll get 0.8416. You just get them all from your calculator. It's not you don't have to think about it too much. And then to translate between z and x's, because this here is just a transformation, we can just plug in z equals z into here, and then x equals 5.9, x equals 5.9, and then similarly here just with the other values. And then we can just solve these simultaneously. So if we arrange for sigma, we would plug it into there. We just go through slowly, multiplying both sides, multiply by this on both sides to get this, distribute this, and distribute that. Then we can go ahead, collect the mu's, and then divide by this on both sides to get 5.81. And then just plug it back into either of the equations to get sigma, which is 0.34. This is the last question of the paper, I think. It's a binomial distribution question, hypothesis testing. Straight away, we just need to put down h0 is 0.7. Okay, and we've also got that the alternative hypothesis is greater than 0.7, because here it says that it increases. Okay, and alpha is just 0.025. It's just this because it's a one-tailed test. Okay, and as I said earlier, the way that we do this is we assume h0 is true, and then we assess what happens under h0. We've got n as 25, and then the probability is 0.7, and then here I think it's just always a good idea to define what x actually is. Okay, X is just the number of businesses that made profit in their first year. Okay, so we're just relating it back to the question, and we're looking for greater than, so we need to see how likely it was to have greater than or equal of to 21. Okay, this is 1 minus the probability that X is less than or equal to 20. Now, because the binomial distribution is a discrete distribution, we do need to be careful about changing these limits. Okay, this just goes into calculating egg normal. You'll get this. Okay, then we compare it against the significance level. 0.025 is less than 0.0905, and because this value, this probability is so low, it's so extreme, it's so low that it would doubt the credibility of H0, and so we feel sorry, no, it's greater than that, sorry, I misread this. Because it's greater than the significance level, we fail to reject it because the probability of it being a coincidence is greater than the significance level. There isn't sufficient evidence to suggest the proportion of businesses that made profit last year increased. Make sure that your final concluding statement is actually linked to the context of the problem. I think you can drop a mark if it's not. Let me go back to what I was saying earlier. So if this value here was lower than the significance level, it would be so low that it would doubt the credibility of H0, and so we'd have we'd be less likely to believe it, kind of. This probability here represents the probability that this event here was actually a coincidence, and if this like supposedly anomalous result was actually a coincidence, which has a high percentage of being a coincidence, okay, then we wouldn't straight away jump to conclusions and therefore reject H0. So we fail to reject the H0, in other words, accept it, and so that is why we do that. That is the entire paper. Thank you for watching.